I'm Deepak Chopra, and I'm here in England, in Hampstead, with Dr. Ρούπερτ Σέλντρεϊκ. I've been a big fan of his for as many years as I can remember, and I'm very fortunate today to be able to have a conversation with him. And we'll do this in several parts. So I'm going to start, Ρούπερτ. First of all, thank you for inviting me to your house.
I'm very glad you're here.
And we want to talk a little bit about your background. So you grew up in...
I grew up in England. I was born near Trent in Nottinghamshire.
Mm-hmm.
I went to a boarding school. Then I went to Cambridge. And from the earliest age, I was really interested in biology. I kept animals. I had lots of pets. My father was a herbalist and a pharmacist, and he taught me about plants. So I was interested in plants and in animals. So I knew I wanted to do biology.
So you did your college degree in biology?
I did it in biology, yes. But even when I was doing this degree, I felt that the standard mechanistic approach was too limited. I felt treating animals and plants as machines was leaving a huge amount out. So I began to question it, and I got to the stage where I wasn't sure if I really wanted to go on doing biology. I did very well, and everyone thought I should do research. So I was lucky to have a year at Harvard where I did history and philosophy of science, which enabled me to step back and look at the bigger picture. And that really gave me a broader perspective, the idea of paradigm shifts. The mechanistic theory in biology didn't necessarily have to be the ultimate truth. And that really started me on a path that I've been on ever since, of trying to find a kind of science that's more inclusive, that still is science based on the scientific method, but which doesn't fit into this narrow dogmatic framework.
So, I'm trained as a physician too, and my training was in neuroendocrinology and looking at the hormones of emotion, if you will, neuropeptides, studying things like molecules like serotonin and dopamine and oxytocin. That led me later to question the mechanistic paradigm. As a physician, I could have two patients who received the same treatment for the same illness. They saw the same doctor, but they could have completely different outcomes. And so I started to question the mechanistic approach we had in medicine, but particularly our understanding of biology. When was it in your career that you began to see the inseparability of molecules and mind and consciousness, or where was the turning point for you that actually, in a way, solidified your point of view that reductionism and mechanistic frameworks don't work?
Well, I was doing research at Cambridge for my PhD in plant development. And I worked on plants because I didn't want to spend my career killing animals, and research on animals basically involves killing them all the time.
Yes.
So I was working on how the main plant hormone, Auxin, is produced, and I discovered it's made by dying cells within plants. The cells that become the wood cells in plants, they are dead empty tubes that conduct water there like little pipes. In order to become wood cells, they die. And as they die, as the proteins break down, they give off a whole range of breakdown products, one of which is the main hormone that gives more life. So here, for me, this was very exciting, that the key to life in plants is death within them. That death and life
makes life possible.
Exactly. So this was a remarkable finding. And I then went on to work out the mechanism of polar auxin transport. This hormone is transported around the plant towards the roots in a polar way, from shoot to root. And when that had happened, this was a major breakthrough, and this is kind of textbook stuff now, the polar auxin transport thing. I then realized that the very same auxin, same hormone, is present in all plants, in all parts of the same plant, you know, in petals of a rose, and the leaves of the rose, and the spines of the rose. Yet they all have different shapes. So the attempt to explain all this shape and form in terms of chemicals seemed to me doomed to failure, because this one-size-fits-all chemical couldn't possibly explain the diversity of forms. So I got interested in an idea that was already there in biology since the 1920s, morphogenetic fields, invisible form-shaping fields. These give a kind of holistic patterning of plants and animals. There's leaf fields that shape leaves, petal fields that shape petals, and so on. These fields have a kind of goal. They draw things towards an attractor, a goal. But at this stage I wasn't, this is mind-like, but at this stage I wasn't particularly concerned with consciousness. I was working on plant form and came to the idea it must be holistically organized. Then I realized the same applies to animal form. Then I realized that the organization of the nervous system in animals must depend on fields, similar to these fields. Then I thought, how do these fields work and how are they inherited? I then came up with the idea, when I was working in Cambridge as a research fellow, of morphic resonance, a kind of memory in living organisms that's carried through these fields. And this really changed everything. I suddenly had a hypothesis that could predict a lot of new phenomena that I could test, and which cast a whole new light on the way biology and minds work.
Let's talk a little bit about these fields of morphic resonance. They're not in the physical realm. They're not even at the level of energy. They're like platonic forms, would you say?
Oh, no, they're not platonic forms. The problem with platonic forms is that they're outside space and time. They don't evolve.
They're like platonic forms, would you say?
Oh, no, they're not platonic forms. The problem with platonic forms is that they're outside space and time. They don't evolve.
So they are in space-time.
Oh, they are in space and time. So my morphic field is within and around me, and it's within my body and around my body, like a magnetic field is within and around a magnet.
But the morphic field is not an electromagnetic field.
No, it's a different kind of field. You see, we've already got several kinds of field in nature. They're all different. Gravitational fields, which hold us down now. We're not floating around because of this invisible field.
Correct.
Electromagnetic fields, light, radio waves, and so forth. In quantum theory, a whole series of fields, electron fields, proton fields, neutron fields, each kind of
particle
has its own kind of field. There's dozens of fields. And what I'm suggesting is that it's not just in quantum phenomena at the microscopic level that there are these fields. There are fields for each kind of molecule, for each kind of cell, for each kind of tissue, for each kind of animal and plant. And that these fields are organizing fields that are in space and time, and they have a memory. They depend on what's happened before. So the way a palm tree grows depends on the way previous palms of that species have grown.
I'm just trying to come to grips with the morphic field as it relates to what we ordinarily know in science as these other fields, the electromagnetic fields and so on. So would you say that these morphic fields are like possibility waves, or before they actually become measurable?
Well, the point is all fields are measured through their effects.
That's
I mean,
right.
this room's full of the gravitational field.
Correct.
We measure it not through an electric meter or anything, we measure it through its gravitational effect, the way it affects a pendulum swinging, for example, or the way it pulls things towards the Earth. So all fields are measured through their effects. All of them are invisible. This room is full of the electromagnetic field, and we're seeing through it, but there's a lot of it we're not seeing through because there's infrared, ultraviolet, X-rays and so forth. So all fields are known through their effects, and what morphic fields do is create a kind of form or organizational pattern. They attract developing systems towards what I call morphic attractors. They're fields of possibility that influence quantum and other possibilities. Everything is indeterminate in nature. It could do one thing, it could do another. And if you have a higher level of organization that makes something, it could do that, this higher level, push it that way and not that way, they have organization imposing form. So that's how morphic fields work. And they work through, the form they have depends on this memory. So I'm not saying that they're outside space and time. They're inside space and time. They're physical, they're part of nature, but they're just not part of existing physics, because existing physics hasn't yet taken this kind of field on board. So I'm not saying that they're outside space and time. They're inside space and time. They're physical, they're part of nature, but they're just not part of existing physics, because existing physics hasn't yet taken this kind of field on board. But when it does, then we'll expand our field theories. We've already got all these other kinds of fields.
So, in some of the Eastern wisdom traditions, and particularly the one that I relate to, Vedanta, which is the basis of Ayurveda as well, we have a kind of a top-down approach to reality. So there's first consciousness, which is a field of all possibilities, infinite potential. Then from consciousness we have what we refer to as the causal realm, which is basically memory, karma, and impulses of intelligence. Then from consciousness we have what we refer to as the causal realm, which is basically memory, karma, and impulses of intelligence that would then manifest as what we call the subtle body of mind, intellect, and ego. And then in the human microcosm, but everything else has the same kind of layers: consciousness, memory fields, which would in a way relate to your morphic fields, then the subtle body, mind, intellect, and ego, then the energetic body, which is called prana, and finally the physical body through which we experience the world. It's consciousness, morphic fields, mind, intellect, and ego, which can be literally measured now as, say, electromagnetic activity, at least in the brain, and then energy and matter. Does that make any sense to your model?
Well, yes, it does. I mean, my model doesn't itself predict the higher level of consciousness. I mean, that is a framework within which one could put this model. But the idea of a top-down system of organization is certainly part of the model. I mean, it's both. It's top-down and bottom-up, because just as in our body, the whole body is affected by the organs within it. They're affected by the cells and the tissues and the genes and the molecules and so on. There's both influence from lower up, bottom up and top down. But if we look at the way the universe is organized, it's in a series of levels, like galaxies containing solar systems, containing planets, like Gaia, with a whole top-down system of organization of the atmosphere and so forth. Then ecosystems, and then organisms with organs and tissues and cells and molecules. I mean, there is this top-down level, and there's also the bottom-up level. So I think we need both, and I think it fits quite well with the Indian version, the sort of traditional Hindu idea of karma as a sort of memory in nature. And I found when I was first developing the idea of morphic resonance as memory in nature, when I discussed it with colleagues in Cambridge, most of them were completely baffled, because Western thought doesn't have memory in nature. For Western philosophy from Plato onwards, memory is amnesic. Nature's amnesic. There's no memory in nature. Everything's determined by Platonic forms or mathematical equations outside space and time. Whereas in the traditional Indian worldview, there's a kind of memory within nature which fits much better with what I'm saying.
But the memory in nature exists as possibilities. Or probabilities, you might say. It's not. So if I asked you a question like, what did you have for dinner last night? So what did you have for dinner last night?
Fish and vegetables.
Okay. Where was that memory before I asked you the question? I can't go into your brain to look for that.
No.
Or you have a vocabulary, let's say, of 10,000 words. You're just using a few of them right now.
Yes.
Where is the rest of it? And, what the Vedantic view would say, it exists in that field till you retrieve it. It's almost like the collapse of a wave function. And then there's, of course, activity in the brain.
Yes.
But before that, it's part of the field.
Well, I would say very much the same. The thing is, you see that, well, first of all, there's two kinds of memories. Most memories in nature, in species, like instincts in animals, are habit memories. And I would say that the bulk of nature is habitual, works on habits. The so-called laws of nature are actually more like habits. These are the regularities of nature based on memory, which becomes habitual and largely unconscious, because habits, even in us, are unconscious. When you come to episodic memory, the memory of specific things, like dinner last night, then it's of a particular event. If you asked me to remember dinners in general, then there'd be a kind of blur of memories,
Sure.
thousands of dinners. But a particular one, then there's a specific memory about a specific event. But like the habit memory, this isn't stored in the brain, on my view. The brain's more like a receiving apparatus, more like a TV receiver than a video recorder. So you're tuning it in, you're tuning into it. Now, the reason I prefer the resonance metaphor to a version of the field metaphor for memory storage is the field implies there's some kind of something out there in space. And some people talk of the Akashic record, imagining some kind of celestial filing cabinet system or hard drive or something. I don't think we need a spatial metaphor for memory. Memory is a relationship in time. When I meet someone I haven't seen for ages and I recognize them, what I think is happening is I'm resonating with the previous time I saw them. And there's a resonance across time. It's just leaping across time. I don't think in the meantime it has to be stored somewhere in space. You see, if it's possible for there to be connections directly across time, then we don't need to use these spatial metaphors. I don't think we need a spatial metaphor for memory. Memory is a relationship in time. When I meet someone I haven't seen for ages and I recognize them, what I think is happening is I'm resonating with the previous time I saw them. And there's a resonance across time. It's just leaping across time. I don't think in the meantime it has to be stored somewhere in space. You see, if it's possible for there to be connections directly across time, then we don't need to use these spatial metaphors. If we have spatial metaphors, then people say, well, where is it? You know, the Akashic record in the ether, or is it in some kind of cloud computing storage system, or a kind of celestial hard drive? I don't
Could
think
it not just be possibility waves?
Well, I think they are possibility
Yeah,
waves.
so then-
I mean, I discussed morphic resonance and morphic fields with the late great philosopher of science, Sir Karl Popper, and he thought that the best way of thinking of them was propensity fields.
Propensity fields.
So they're fields of possibility, but they're not just fields of any old possibility, they're fields which make some possibilities much more likely than others. They're fields of habit, or fields of propensity.
Yeah.
Yes, they are. They're fields, and they work by resonance. So there's a particular pattern of activity in my brain when I see someone I've seen before. It sets up a characteristic electromagnetic pattern. This pattern interfaces with the experience, the morphic fields of that experience last time I saw them, and there's a resonance across time. We don't, if it's a resonance across time, like a kind of spark passing across time, it doesn't happen until I see that person. When it happens, then I enter this resonance. But it's not necessary to suppose that in the meantime it's been stored in some spatial storage system. Maybe it has.
I was watching recently a video on one of these YouTube channels or something else from Frank Wilczek, who won the Nobel Prize in 2011 for discovering yet another particle. He's at MIT. But he was saying that there's a resurgence now of the idea of the so-called ether. And he wouldn't call it the ether, he would call it the grid. Or the matrix, which is a popular word. And he showed a video. He said if you had an instrument which was very refined, kind of, he called it an ultra stroboscopic nanoscope, which you could look deep into the nature of inner space. And he actually showed it visually. It was very beautiful. If you could look into the structure of deep space where we are right now, which exists in our body and outside of our body, and this is 10 to the power of minus so many seconds and so many centimeters. And then he showed these gluons and these subatomic particles coming out of empty space, colliding, and then going back, except a few that seem to be gushing out as the universe. And you know, other physicists have commented that every cubic centimeter of space has enough energy to make the universe over many times.
Yes.
So I wrote to him, I said, is the universe coming out of this so-called grid, invisible, right this moment, you know? And I asked other physicists that, and they said yes. But then I said, it seems to come out the same way. I mean, you know, we still have the Milky Way galaxy and stars and you and me and insects. So does this have some kind of organizing principle there, or a memory of sorts? So I wrote to him, I said, is the universe coming out of this so-called grid, invisible, right this moment, you know? And I asked other physicists that, and they said yes. But then I said, it seems to come out the same way. I mean, you know, we still have the Milky Way galaxy and stars and you and me and insects. So does this have some kind of organizing principle there, or a memory of sorts? I never heard back from him, but I did hear back from other physicists who did say that, you know, they resonated with your idea of morphic resonance.
Yes.
And memory as part of this matrix or womb of the entire universe, from microcosm
Yes.
all the way up to stars and galaxies.
Well, the quantum physicist David Bohm took that view. He
Yes.
thought that it comes out of what he called the implicate order.
Correct.
And the implicate order has a kind of memory. Something that's happened gets folded back into the implicate order from the explicate order, which is the world we know. And then it's in the implicate order, so next time it happens it will be influenced by what's happened before. So the implicate order, a quantum concept of his, contains a memory. And the quantum physicist Lee Smolin wrote a book recently called Time Reborn,
Yes.
in which he puts forward what he calls the principle of precedence, things that have happened once are more likely to happen again.
But once in a while there's a break in that, right? Would you call that a creative leap in evolution?
Yes, well, the point is that both Smolin's idea and Bohm's and morphic resonance, my own idea, give the idea of habits. And they explain the fact that nature goes on in very similar ways over and over again. The trees grow the same way generation after generation, and stars go on behaving the same way, and so on, most of the time. But evolution obviously has to depend on more than habit, because otherwise everything would just end up in grooves of habit, nothing would change. So evolution has to imply an interaction between habit and creativity, an interplay. If we only had habits, nothing would change. If we only had creativity, nothing would ever stay the same. And so what we have, and what we know from our own experience, is that we're all creatures of habit. But against this background, creativity is possible. And creativity is exploring new possibilities. Not all of them work. There's a kind of natural selection at every level in the universe, including human ideas. And every week, hundreds of new patents are published, and most of them you never hear of again, and new businesses start, and most of them disappear. And so there's a constant weeding out of creativity. There's always far more creativity around than can survive in most
So what
areas.
you're basically leading up to is an entirely new model for evolution. It's not random mutations and natural selection. It's actually organizing principles, morphic fields, leaps of creative imagination, its previous habits, and it's what seems to me something that could only happen in consciousness as a field itself, because creativity implies that to me anyway.
Yes, it's hard to know. Creativity is the ultimate mystery. The philosopher Bergson said that who's one of the main influences on my work, the French philosopher, end of the 19th century, said that we hate the idea of creativity because you can't explain it, that it's something new. And so in the West, the way of dealing with it has been saying, well, there must be platonic forms for everything that's new. Timeless potentialities that are sort of dusted off and come into manifestation when the time is ripe. But he preferred the view that the universe is made up as it goes along, that there's an actual creativity working in and through the evolutionary process.
Through trial, error, experimentation.
But he preferred the view that the universe is made up as it goes along, that there's an actual creativity working in and through the evolutionary process.
Through trial, error, experimentation.
Yes, well, evolution itself would involve some natural selection,
Sure.
filtering out this creativity. But even if we look at human creativity, it's rather hard to say how it works. I mean, sometimes most people who are creative, you get a flash of insight. It suddenly comes to you, a new pattern emerges. But there's two different theories of, well, three main theories of creativity. One is the bottom-up theory. It wells up from the unconscious, for example.
But what is the unconscious?
Well, exactly. The other is it comes down from a higher level. It's inspired from higher levels of consciousness. And then the third is, of course, the compromise position. Well, maybe there's both bottom-up and top-down. And then the third is, of course, the compromise position. Well, maybe there's both bottom-up and top-down. Because there is a bottom-up aspect, you see, because sometimes if you have an accident and you're crippled and you can't go on with your normal life, then necessity is the mother of invention. You may develop some whole new career, some whole new way of living your life that you would not otherwise have done. And the accident may not have come from a higher source, it may just have been an accident. So there are things that can influence what happens to us which are not necessarily directed from above, as it were, from a higher, more inclusive source, but which, together with it, lead to creative leaps.
Before we finish this segment, what would you say is the practical application of this model? Morphic resonance, habits, creative leaps, organizing principles, natural selection, all put together, as opposed to the classical mechanistic random mutations and then natural selection.
Well, morphic resonance is a kind of memory principle in nature, and I think it applies in chemistry and biology and enables us to understand heredity in a new way. You see, the standard view is it's all in the gene, or now in the gene plus epigenetic modifications of the gene. Well, morphic resonance is a kind of memory principle in nature, and I think it applies in chemistry and biology and enables us to understand heredity in a new way. You see, the standard view is it's all in the gene, or now in the gene plus epigenetic modifications of the gene. But I would argue that actually most inheritance of form and instinct happens through morphic resonance. So insofar as it's important to understand inheritance, then it gives us a completely new way of understanding it. And the current theory has led to a problem of 75% of inheritances, the so-called missing heritability problem. And I think morphic resonance would help explain a lot of that. So it would be useful in animal breeding and plant breeding and in training and in education, because if you learn things more easily that other people have learned before, this can be applied in education to make education much more effective.
Would this kind of suggest the reason why every generation seems to be a little ahead of the previous generation?
Yes, I think it would.
You
build on. It's getting easier and easier for people to learn skateboarding, windsurfing, all these new sports, computer programming, playing video games, etc. And in fact, there's a phenomenon called the Flynn Effect, where there's been a rise in IQ of more than 30% over the last 70 years, which can't be explained in any normal way. And I don't think it's because people are that much smarter. I think the tests are getting easier. If you do standard tests that people have already done, they'll get easier to do.
I see.
So those are some areas. Morphic resonance sheds a new light on memory. If it's not stored in the brain, then we might look at memory defects and memory problems in a different way from spending all the time and energy on looking at neurotransmitters and things. They do play a part, obviously, but that's not the whole story. And it's possible that it might even have technical applications, because if you can get crystals to behave in a new way in one place, and then crystals all around the world behave in a new way all around the world, you've got a method of transmitting information without wires and satellites, and moreover one which would have a global memory bank built into it. So it's possible that in the longer run there could be an entirely new kind of technology.
My very special guest on this segment has been Ρούπερτ Σέλντρεϊκ. We've been talking about morphic resonance, looking at nature in a manner that is not so mechanistic, looking at evolution that seems to render the old models of evolution obsolete, and looking at new ways to evolve and learn. Thank you, Ρούπερτ.
Thank you.
Your idea is so fascinating because you're not even talking about biological life transferring information through genetics. You're talking about it through some unseen force that has yet to be defined. And that's when things get really squirrely. And is that when you, must be when you experience the most resistance to these ideas? Because the resistance to these ideas, I'm sure, before they proposed this idea that genetics or that these mice would somehow or another inherit the fear of the smell from their parents, that was probably not very well received before it was proven. But then it was proven, so now it sort of has to be accepted and has to be taken into consideration. But your idea is still very fringe.
Oh yes, it's the interesting thing is, you see, the response I get to this from some scientists is actually extremely emotional and irrational. When my first book, A New Science of Life, came out, there was a very famous editorial in Nature, after the leading science magazine, a few months after the book appeared. To start with, Nature ignored it. But then a lot of people got interested. I was doing programs on the radio in Britain. There was an article, editorial in The Guardian, saying what an interesting idea. And there's a lot of serious discussion going on. New Scientist magazine launched a competition for the best ideas for experiments to test morphic resonance. And it was beginning to be widely discussed. The editor of Nature, who was a reactionary figure in science, a old-style, materialist, mechanistic, hardcore scientist, wrote a famous editorial called A Book for Burning on the front page of Nature, comparing my book unfavourably with Mein Kampf, Hitler's book, saying that this was a profoundly dangerous book.
Wow.
And he said this is the best candidate for burning there has been for many years. And it was completely irrational, this attack on my book. It was emotional, irrational, polemical. He didn't do it as a joke. This, of course, produced a backlash because quite a few scientists thought this was the wrong way to respond to a scientific hypothesis. So a lot of letters in Nature for months afterwards were backing me up and saying, this is something that should be seriously discussed, not simply denounced. But the fact is that this started a kind of controversy which has been going on ever since. But until the year 2000, most biologists thought genes did everything. Now, the epigenetic thing has taken over and the missing heritability problem. There's much more openness than there was because it's clear we haven't figured it all out. Interestingly, Charles Darwin was not a neo-Darwinian. Neo-Darwinian evolution theory says it's all done by the genes. Evolution's just about random mutation and natural selection of gene frequencies. This is the basis of Rítsarnd Dawkins' work, for example. His book, The Selfish Gene, is based on that model. Darwin actually believed in the inheritance of acquired characteristics. Darwin actually believed in the inheritance of acquired characteristics. He thought that animals could inherit the fears of their fathers and that most of adaptation could actually be passed on to animals and plants descended from parents. He thought that was how evolution worked. He even proposed that when something had been learned, there could be movement of something through the bloodstream that could affect the sperm and the eggs. Exactly the kind of things that's now being considered in this fear of the father's case.
So movement through the bloodstream. So if you learn something, like say if you touch something, it's an electric fence, and it shocks you, there's movement through the bloodstream that teaches your sperm this?
Well, that's what Darwin thought.
Wow.
He wrote a book called The Variation of Animals and Plants Under Domestication. It's less well known than his most famous book, The Origin of Species. But in the variation of animals and plants under domestication, he was so convinced that plants and animals could inherit what their parents had learned. He tried to figure out how it might work, and the last chapter is called The Hypothesis of Pangenesis. It's the name he gave to his theory that somehow little bits were detached from the brain and went through the blood and affected the sperm. Now, that's more or less what people are saying, trying to explain the mice inheriting the fear of their fathers. That aspect of Darwin's work has been airbrushed out of scientific history. Darwin also wrote a paper in Nature about a dog that he came across, that whenever this dog got near to a butcher's shop, the dog was completely terrified of butchers. And Darwin figured out that its parents, one of its parents, had been kicked or badly mistreated by a butcher, and this dog had inherited a phobia of butchers. Now, Darwin published that in Nature. That shows you how very different Darwin's ideas on evolution were from his 20th century successors, and the reason that modern evolutionary theory is called neo-Darwinism is to distinguish it from Darwinism, which included the inheritance of habits. Very similar to what I'm saying. What I'm saying in terms of the inheritance of habits through morphic resonance is actually really close to what Darwin himself said. But it's not what neo-Darwinians say, because they've tried to say all inheritance is in genes and you can't have these other things. But now they have to change their tune because, as I say, in the last few years, epigenetic inheritance, the inheritance of acquired characteristics, is back in fashion.